Aloha and welcome. In this video, we're going to be talking about wireless communications. Wireless communications is all around us. We use wireless technology uh, all the time. We've got it in our phones. We've got it in our computers most often. We've got it in our credit cards. We've got it in, the headphones that I'm using. These are Bluetooth. That's wireless technology. So we use wireless technologies a lot. So we're using radio waves essentially to send data between devices. So we're doing it. You think about it, you can't see it, but like right now, I can hear what I'm saying because my voice is going into a microphone that's going back wirelessly to my computer and it's coming back through my headphones. So I can hear my own voice this way, which is pretty incredible. So, all this is happening invisibly. We can't see this, but we're sending data through space all the time. So we've got two characteristics really of these radio waves, and one of them is frequency. And when we're talking about frequency, we're talking about the number of times a wave goes in a given second, and we're talking about amazing numbers here. When we talk about gigahertz, capital GH and a lowercase z, we're talking about the things that are they're measured in billions of events per second. So in other words, if it's just a regular wave, you're talking about how many billion. So if it's 2.4 gigahertz, you're talking about 2.4 billion times a second this radio wave will go. And then the other thing is the wavelength, and that's going to be the distance that it travels, and it's usually measured in meters or feet. So you've got other characteristics. The radio frequency, the RF, it's a number, it's a numeric identifier that's used to identify a radio wave's frequency measured in 1 billion events per second. That was the gigahertz I mentioned. We also have a band, and a band is a range of radio frequencies. So when you're using Wi-Fi, we talk about two major bands. We talk about the 2.4 gigahertz and the 5 gigahertz bands. So when we're talking about when we're talking about bands, we usually abbreviate it to either a single number, an integer, or we're going to have we'll have a number with one decimal point after it, and that's used for bands. So another thing to know about radio waves is they have a beginning, a center, and an ending RF radio frequency, essentially. So it's going to start out, and then it's going to rise up to the height, and that's going to be your center. So it's going to start at its beginning RF. It's going to rise up to its center, and it's going to go back down to its ending RF. So that's one complete, radio frequency or radio. It's one, I guess, not oscillation, but it's one. That's the frequency of count of one. And remember, that's going to happen billions of times per second, which is just mind-boggling. But anyway, going back to what we were talking about, you had your beginning, you had your center, and you had your ending RF. Your channel is going to be the radio wave's center RF. So it's going to be that height there, the center one. So not your beginning or your end, but the center one up at the top. So moving on with this, when we talk about signals, wireless signals, they're electromagnetic waves that are traveling through the air, as we discussed. They're formed when electric energy travels through a piece of metal like an antenna producing waves. And you've seen, well, you probably can't see it in your phone. Your phone has antennas in there, but you can't really see it because it's internally. But it's all caused by, these waves are caused by the electricity flowing through this piece of metal. So these waves can travel some distance depending on the signal power and environment. And examples are like, well, actually, yeah, they get broken up by things like concrete, wood, metal walls, or different things that are there to prevent the signals from traveling. So wireless devices use these signals in the transmission of data. The signal frequency determines the type of transmission used. So we're talking about the types of wireless signals. We're talking about 4 different kinds here. We've got narrowband, and that's going to be a signal that occupies a narrow frequency range and has a small bandwidth. Then you've got the wideband signal, and that has the opposite, a large bandwidth. Then you've got broadband, and broadband is broadband is wide bandwidth data transmission, generating an analog carrier frequency, which carries multiple digital signals or multiple channels. So broadband can be used for transmitting cable TV. So when you look at your house, you probably have some coax cable. That's what carries those signals. So in the context of internet access, broadband is any dedicated internet access with higher access speeds than dial-up. Probably none of you remember dial-up, but in the old days, we would actually take a phone, we would put it into a coupler, a modem coupler, and we would send signals over phone lines in order to communicate. And the last one after narrowband and wideband and broadband is baseband. And baseband is the frequency range occupied by a signal before it's modulated. So baseband radio processor, a BP, also known as a baseband processor, it's a network interface controller chip that manages the radio functions. So a synthesized tune or a microphone audio signal output uses a baseband signal. So moving along, there's several different common wireless technologies out there. I mentioned some of them earlier. One of them is infrared. Infrared sends data over a high frequency infrared connection. So an IR wave, it can't go through anything like walls and things like that. So you're talking about line of sight types of communication. So think of it like your remote control when you're controlling a TV or something like that. Or I have an air conditioner, and the air conditioner uses a little remote control and to control that. Those are infrared. You also have Bluetooth, and Bluetooth is low power, short range wireless technology that pairs two devices. For example, the headphones I'm wearing right now. Also, if you've got AirPods or AirPods Pro or whatever you have, those are also Bluetooth. It's often used to connect devices and peripherals. We also have Wi-Fi, and Wi-Fi uses a router to connect devices to each other in the internet. So Wi-Fi is the most common wireless technology used in home and office networks these days. Then we've got cellular, and cellular is what your phone uses to connect. So your cellular, devices like your phone, it's going to use cell towers. It's going to connect to a cell tower, like AT&T or Verizon's cell phone towers out there. And all the data sent using cellular technology travels through a network that is managed by an outside organization. So there's different things to consider when you're looking at these common wireless technologies, and there's a chart in the book that goes through all of this. But you should know the characteristics, particularly the range of these, and some of the examples. The frequency bands for some of them, like Bluetooth and Wi-Fi, you should know. You should also probably keep in mind the IR and the cellular, but those are a little bit wide on the ranges. So with infrared, we're talking about a range of 3 to 30 feet. So you just think about the distance that your remote control would travel. It's about the same. Well, it's exactly the same. So about 3 to 30 feet. Your frequency bands are going to be the higher bands. It's going to be 315 to 344 gigahertz. The band width is going to be up to 16 megabits per second. And it's used for things like TV controllers or air conditioner controllers, things like that. Then you've got Bluetooth. Bluetooth has a range of about 30 feet. Think about how far you can get from your computer before you can't hear anything on your headphones anymore. That's about 30 feet or so. It operates in the 2.4 gigahertz range, the same as your Wi-Fi device, and I think microwaves as well. And the bandwidth on this is about 2.1 megabits per second. And examples, wireless headphones, fitness trackers, things of that sort. You've got Wi-Fi. Wi-Fi has a range of about 150 feet, depending on if you have things in the way. Wi-Fi can go through walls and things like that, but you'll find that when you're dealing with Wi-Fi, your 2.4 gigahertz band will go further, and it's a lot more reliable. But the 5 gigahertz has a lot more bandwidth, but it's for a shorter distance. So if you're close by your router, by all means use the 5 gigahertz connection. But if you're like on the other side of the house, or if you're outside the house even, you want to go down to your 2.4 gigahertz because that's going to be a stronger connection. An example of that is I have at my in-laws, we use wireless cameras, and I have a router in one, or a wireless access point essentially in one part of the house, and outside in a shed I've got the camera, but the camera operates on the 2.4 gigahertz, so it can actually go all the way across the house through 2 walls and through the shed itself. So your 2.4 is going to carry a lot further. So keep that in mind. And then cellular is the unbelievable 10 miles. So your cell tower to your device, about a 10-mile distance there. It's operating in the 800 megahertz to 40 gigahertz, so got quite a range there. And the bandwidth on that is about 10 gigabits per second. Uh, and examples would be like, any type of 5G, cellular data. You've got, anything that AT&T or T-Mobile or Verizon carry. I forgot to mention Wi-Fi. Again, you've got the 2.4 gigahertz and 5 gigahertz, but the bandwidth on that is going to be about 9.6 gigabits per second. Going on from that, we've got other wireless technologies, some I alluded to earlier. We've got RFID, which stands for radio frequency identification. That uses a tag and a reader. So your tags are going to you use a reader that would go and detect the tags around it. Similar to that, you're going to have the near field communications, but near field communications, like not sure if you've used any technology like this, but like on the phone, you can do near field communication. I've used it in Japan when I go up to different devices and just click on it to let's say I want to get access to the train station with my phone. I can just tap my phone onto it, and the proximity of it they connect, and I can make a payment or something like that way. So that's near field communications, and it's based on the RFID technology, but both devices can communicate with each other. So it's not like RFID, which is you have a tag and a reader and the communication is only one way. In this one, either device can send to the other. Then we've got global positioning systems, GPS. A lot of you are familiar with GPS. Your phone has GPS in it. It's using multiple satellites in space to coordinate or to triangulate your position, and it can do that pretty accurately to a distance of, I think it's probably around 8 feet or so, but it's highly accurate. And also we can change the accuracy of that on the satellites themselves. So in the past, like when we had the war with Iraq, they intentionally turned off a lot of the global positioning systems in that area when they were doing the invasion. They're using encrypted GPS for military purposes, but they turned off regular GPS for everybody else, so that would slow down the enemy or make it where the enemy's equipment didn't work as effectively. Then we've got Zigbee. Zigbee is a low-cost, low-power wireless machine-to-machine M2M and IoT, Internet of Things for networks. And I use those. A lot of lights use those. You can have little devices like LED strips and things that use Zigbee to communicate. And the nice thing about that is it's low cost, it's low power wireless machine-to-machine type of networking. So when we're talking about these different technologies, we also have the range issues. So RFID, the badges that you badge in on, that has a range of about 300 to 300 feet. The frequency bands are varied on this. Like it goes down to the kilohertz, which is thousands, and megahertz, which is millions. And then you've got it doesn't go into gigahertz on this one, but it stays in the lower frequencies. So 125 kilohertz, 13.56 megahertz, and 860 to 960 megahertz. And the bandwidth is also small. It's about 848 kilobits per second. An example that's going to be like your hotel room key or maybe your badge for getting into the office. We've got near field communication, which has a range of about 4 inches. So we're talking a very small distance. And that's operating on 13.56 megahertz. And the bandwidth on this is even smaller than RFID. NFC only has 424, which is exactly half the bandwidth of RFID, and that's used for contactless payments. So if you think about the different forms of paying with digital your watch or something like that. GPS this has a good range. It's about 13,000 miles. Measure the distance from you up to the sky to the satellite. There you go. That's operating on 1,575.42 megahertz or 1,227.6 megahertz. And that has a bandwidth of about 50 bits per second. So that is by far the lowest number of, or the lowest bandwidth of all these technologies. And examples that use this are Google Maps and geofencing. Then the last one, we've got Zigbee. Zigbee has a range of about 10 to 333 feet. It's best under 40 feet. And of course, it's going to vary depending on whether you've got walls in between, things. And those are going to be operating on, globally, it's going to operate on 2.4 gigahertz. In Europe, it's going to be 868 megahertz. And in the US, it's going to be 915 megahertz. Different countries, different standards. So the bandwidth of this technology is going to be about 250 kilobits per second. And again, like I said earlier, it's going to be used for wireless network sensors, light bulb switches, that types of things. So that is our introduction to wireless communications. If you have any questions about this, feel free to reach out and I'd be happy to talk to you about that. Have a great day. Aloha.